Hello everyone, in this video we will be reading out some material regarding the heartbeat mechanism in distributed systems, and we will be digging deep like how it works internally and how it is crucial in a distributed system, because in monolithic system there is no concept of multiple nodes. So single process, single everything, and inter process communications are there. But yeah, here when you decide over a debate or the legit decision in which you need to use distributed systems in your application, then your system needs to have multiple nodes in the sense that each node is it's a name for a server. Like if you want to have a many servers or many databases or a you know uh, many servers having a piece of database distributed. So in all those scenarios, it is very crucial to know like whether are one of the server or one whether any node it's down or not. It's failed if it is geographically located in multiple data centers around the world. Then if some data centers is not responding or it's having a meltdown or it's having a problem, then around the world all those other nodes which are distributed and connected in a way, how they reconcile that, how they behave, how they react on it, and maintaining the goal of a distributed system, which is the main primary goal, apart from many other goals, which is the main primary goal is to have no downtime. Okay, so if that node is responsible for doing some stuff, then how we can handle that and how we can repair it not that physically. Our system will repair this connection or repair you know the user traffic which was earlier serving to that server. But the first thing is came like how do we notice, how do we get notified, or how to know that yeah it is alive or not. And that's where the heartbeat mechanism comes to in the picture. So the premise is already set that unlike monolithic application, we need to have some kind of mechanism to know whether any node is alive or not. So imagine a cluster of servers working together in a processing a millions of requests per second. Yeah, in the case scales of million, we usually need cluster or many servers. If one server slightly crashes, how quickly can system detect this failure and react? How do we distinguish between a truly dead server or one that just temporarily slowing down due to the network congestion? These questions are one of the core why heartbeat mechanisms matter. So yeah, so maybe system or one node is responding very slow, so it's down but temporarily. And network congestion mean that too many connections or too many requests it's handling. So once that limit is crossed, system seems to get it's down, but yeah, it's just waiting. It's just processing all those busy processing those extra requests, and that congestion will end up making that server not responding because it's already have under it's already under load with handling so much of requests. So what are heartbeat messages? Heartbeats, it's like as we in the real world, it was a very useful way or very popular way to know whether a system or where a entity is alive or not in the real world. So in this that's why it's named after that, but not everything in the distributed system names correctly. So keeping that mind, at its most basic level, a heartbeat is a periodic signal sent to one component sends from one component in the distributed system to another to indicate that the sender it's still alive and functioning. Think of it as a simple message that is say I'm alive. Okay, so every few millisecond, few seconds, few minutes, whatever the time period is, one component it's explicitly telling other component or a system that yeah I'm alive. Okay, and that explicit message or that intentional message, it's called a hybrid heartbeat because yeah if it is alive, so it should be sending us some message that yeah I'm alive. Hybrid messages are typically small and lightweight, often contains just a timestamp a sequence number, and identifier. The key characteristic is that they send regularly at fixed interval, creating a predictable pattern that other components can monitor. Since it should be lightweight because it will be sending again and again. It's like a polling. It's again and again, sending the data and it's processing that. So it's should be lightweight. Secondly, it should have like timestamp, sequence number, or identifier. These things will get into the understanding why these are they. You can make a guess like timestamp must be needed because we need to know like when this heartbeat is generated and when it's reached to the server, because it will also help us to like how far and how latency works with that server, because it's also adding up to the response time. Because in the real world, in the request, request will experience the response time. So it needs to be sent fixed intervals, because suppose if some server is continuously sending heartbeat in 5 seconds and suddenly now it's taking 7 seconds, and so after that it's taking 8 seconds, then we that extra seconds, it's signaling something. It's showing something to us, like something is wrong with that server. Maybe it's under heavy load, maybe it's network congestion, or maybe it's another issue. So that this delay is happening right now, so we can do something about it ahead of time. So these are the metrics or things we can keep an eye on. The mechanism works through a simple contract between two parties, the sender and receiver. The sender commits to the broadcast its heartbeat to at regular intervals, say every 2 seconds. The receiver monitors these incoming heartbeats and maintain a record. So yeah, so maintain a record when the last heartbeat was received. If receiver does not hear from a server within expected time frame, it is generally assume that the server has gone something has gone wrong, whatever I said. So there is a simple code, because heartbeat sender, will be a sender and there will be a receiver. So sender will have have interval second configure in it, and the sequence number start from 0, and every time it sends us heartbeats, it's making a sequence number. Also self identification, like which node I am, the timestamp and the sequence number. That's why that identification new, and it's running in a constant loop and sleeping for every 2 seconds or whatever the interval, and it is sending the heartbeat. When the node crashes, stops responding and become isolated due to the network partition, because some networks we cannot, if it is alive but network is not there to be connected. So something wrong with the network, or something wrong with its network card, or the path in which it should be connected over the internet. It is something is wrong there. The heartbeat stop arriving because that connection is not happening. The monitoring system can then take appropriate action, such as removing the fail node from the load balancer pool, redirecting traffic to healthy nodes, and triggering failover procedure, because that server was responsible to handle some traffic, and load balancer is redirecting some traffic to it. Now, as soon as we are not hearing something for 5 seconds or for 2 seconds from that server, we need to react on it, and the system will do some stuff. First, it will inform the load balancer that some node is dead, so do not send the traffic which was intended for it, which was earlier sending to it. Do not send it. Send it to different, some distributed among other servers, or something to a new server, whatever the reaction would be. But yeah, it will know, and that node must not be as expected to perform some action, or to handle some request, because it's not responding, it's presumably dead. So that also the things, triggering failover procedures, which is whatever the post failure procedure we have set in, because maybe that server is doing some critical task, some task which is not intended to happen. Like one example coming into mind, like if you are using distributed transactions, and the the node which will commit, in two-phase commit, which will commit that thing which needed to be completed, that transaction, it's failed. So the second thing is that, yeah, if it is failing, then the whole system need to reconcile and compensate on it. Or same for other saga pattern as well. So the core component of heartbeat mechanism was, or is, the first component is heartbeat sender. The node, this is the node or service periodically sending or transmitting heartbeat signals. In most implementations, the sender runs one on a separate thread as a background thread to avoid interfering with the primary application logic. So it will not be uh, in the same layer of the application APIs, because we need to make those predictable. So it will be running on a separate thread or maybe on separate core, because it can run on parallelly. The second component is a heartbeat receiver or a monitor. The component listens to the for incoming heartbeat and tracks when each heartbeat was received. The monitor maintains the state of all the nodes, and it is tracking, typically storing the timestamp of the last receiver received heartbeat for each node. When evaluating node health, the monitor compares the current time against the last received heartbeat to determine if a node should be considered failed. So there is a not a receiver, it's a monitor, because it needs to do much more than just receiving, and it's looking like a centralized service, because it will have track of many nodes. So as you can see, whenever anything wrong's happening, it will receive the node, it will check the timestamp before from its last heartbeat, and if it is something good, then it will say go ahead, otherwise it will mark that node as failed. So we will get all the failed nodes. Okay. Yeah, so it's getting the heartbeats for all the nodes here for the node ID. Okay, so it is like a centralized service which managing all the nodes heartbeat or all the nodes health. The third parameter is the heartbeat interval, which determines how frequently heartbeats are sent. The interval represent a fundamental trait of a distributed system. Sending heartbeats too frequently wastes network bandwidth and CPU cycles. Sending too infrequently will be slow to detect failures. Most systems use interval ranging from 1 to 10 seconds depending on the application requirement and network characteristic. What is the next crucial thing is there, how to choose the heartbeat interval, like how much it should be, because sometimes the server is just slow. So how we can, you know, like if it is typically taking 3 seconds to respond, and we have made some 2 seconds a heartbeat, and more or less we are wrongly assuming that servers to be dead. But yeah, that server is alive. So we need to have a very calculative, very very critical range, that yeah, this between this to this. After this, after the 4 second, after 5 second, whatever we have the matrix to calculate it, we will set that interval, because either extreme is wrong. If it is true frequent, you know then we are just wasting the life cycle, like wasting the CPU cycles and also the resources or network bandwidth as well. And if it is too late, then yeah, we will ending up mm, having a downtime of few seconds, and it will maybe crucial, maybe causing issues. The fourth one is the timeout or a failure threshold, that define how long the monitor will wait without receiving a heartbeat before declaring it as a failed. So after that heartbeat is received last time, it is having some threshold seconds, that yeah, even after 2 seconds, if it is not responding until next 2 seconds as well, then 4 seconds are too long, I will declare it as dead. Then the whole post dead process is started. Deciding heartbeats interval and timeouts. While a system is very short interval, uses a short interval, such as sending heartbeat in every 500 milliseconds, it can detect failure quickly. However, comes at cost. Each heartbeat will continue network bandwidth, large cluster, and hundreds and thousands of nodes. Cumulative traffic becomes significant. Additionally, very short interval make them system more sensitive to transient issue in the brief network congestion or garbage collection pauses, because sometime a system get network congestion, and that is bound to happen, and that is normal. Same for garbage collection pauses. For to collect garbage, our system pauses for a moment, you know and that is supposed to happen. So that will may count wrongly counted into the failure of the red node, because we are using 500 millisecond, which is too less. It will get us a almost real time feedback or real time, health of every node, but it has these downsides, because even the wrong scenarios, or even the the healthy node will ending up looking like it's not healthy. Consider a system with 1,000 nodes, with each node sending a heartbeat centralized every 500 millisecond. 2,000 heartbeats message per second just for health monitor. So in a busy production environment, the overhead can interfere with the actual application traffic, because maybe our traffic is intended to handle some other important task, and heartbeat is just for checking the health. Yeah, it's important, it's all neat, but it should not contribute to the main traffic unless it is that important case. Okay. Conversely, if the heartbeat is too long, say 30 seconds, the system becomes sluggish and detecting failure. Node could crash, but the system will notice after 30 seconds or more. During this window, request can continue to route it to the failed node and resulting in using failure error. So for maybe 10 to 20 to 30 seconds of not responding a server, user get errors. So that is, bad user experience. Similarly, the timeout value also account in the network struct character. Same for, network timeout. Timeout, like what we have discussed, that it will wait for some time to assume that, yeah, maybe server is not dead, maybe it's just slow for some reason. In a distributed spanning system spanning multiple data centers, network latencies vary, and heartbeat sending from node in California to a monitor in Virginia might take 80 milliseconds just for that under normal condition, and it can spike into 200 milliseconds in the period of congestion. Hence, the timeout is set too aggressively. These transient delay would get false alarm. Yeah, that is self-understanding. A practical approach is to measure the actual round trip time in a network. Use that at the baseline, and many system follows the rule of timeout in the easier at least 10 times to the round trip. For example, if the average round trip is 10 millisecond, then the timeout should be 100 millisecond for a service to variant, because the spikes. And also it could be different heartbeat variables for different type of nodes, because if it is in same vicinity, then it is bound to happen very fast. So, and there is an, there is a possibility, then we can, yeah, we can make its interest increase in number or decrease in number, because we will get respond very quickly. But for the longer distance node, these things need to be considered, like, yeah, we will add up those things, because it will not ending up giving us false alarm. Another important consideration is the concept of multiple missed heartbeat before the declaration failure. Rather than marking a node as a dead after a single missed heartbeat, system wait until several consecutive heartbeat miss. This approach reduces the false positive, causing the packet loss or momentary delays, because the system is too tight, too eager to declare a failure. We need to handle some more cases, where that system is hanging for some reason, or it will get unpredictable. So we will have a number also, that, yeah, two or three misses, then we will call it, yeah, it's a miss. But we will keep that in mind in tracking, because sometimes it's just a, it's just a hint before the failure. It could be. So for instance, if we send heartbeat every 2 seconds and require 3 miss heartbeat before declaring failure, a node will need to responsible for 6 seconds and before being marked as failed. This provide a good balance between quick failure detection and tolerance for transient issue. Now in the next video, we will be trying to discuss the push and pull methods of heartbeat model. Okay, so let's end this video here, because it's already a little bit long on the longer end. But you need to comment every basic fundamental or any questions in the comment, because I need to know, like, how creative and how deep or how naive or how, you know basic questions thinking comes to the people mind, because it needs to be there. Okay, sometimes we try to catch up with the level of that seniority, maybe, or maybe some, you know justifying our experience, and try to question in that level, but that kills the creativity. because what the fundamental questions comes to a new brain or new concept to learner, those questions are very variable, because that will lay out the foundation. And those questions, if they get buried and they will come up pop up in the later in the career, then those gaps already makes your foundation very weak. And yeah, it can be fixed later on, but yeah, what if it's fixed then and there in the beginning? Then the architecture become very beautiful and very strong. So let's check on the next video.